Assalamu alaikum and good morning, everybody. We are going to discuss about the section one. It's about the short questions in the pre-board exams of F.Sc College. So here in front of you is the first question, and this is about the right function of magnesium perchlorate and potassium hydroxide in combustion analysis. So this is the book line, like you can see the highlighted line over here. Hydrogen is converted into water and carbon is converted to carbon dioxide. So in organic compound, when we are analyzing carbon, hydrogen, and oxygen, so what we do, like when water is produced, it is absorbed by MgClO4 whole twice, and 50% potassium hydroxide is used to absorb carbon dioxide. So is the answer, you have to write it in a very proper way. So you will get 2 marks, like magnesium perchlorate is used to absorb water, while carbon dioxide is used to 50% potassium hydroxide is used to absorb carbon dioxide. So this is also mentioned in the diagram as well. Diagram is not necessary, like you don't have to make the diagram in short question, but what all you need to do is just you have to write in a very proper way. So you will get 2 out of 2 marks. Okay. The second thing is about differentiation or differentiate between empirical and molecular formula. So empirical formula gives the simplest formula or simplest whole number ratio, while the molecular formula will give you the actual number of atoms or actual whole number ratio of atoms present in a compound. Remember that whenever you are getting this type of question, you have to write the example. So you can give one example that have the empirical formula as well as the molecular formula. In your book, CH is also mentioned, and you can write CH, and the molecular formula is C6H6, which is benzene. Okay, the third question is about the calculation of the percentage of nitrogen in urea. So here we go. This is actually question 14 in your book. It's a very important question. You can try the other parts as well. So in urea, uh, now you'll see here that with urea they are mentioning the formula, but in question they are only mentioning the name, not formula. So what you have to do, you have to remember the formula of urea as well. It's a very common formula. So it contains 2 nitrogens, and the molecular mass of urea is 60. So we have 2 nitrogen, 14 into 2 divided by 60. That is equal to 28 by 60 into 100. So we'll get 46.67% of urea. Okay. The fourth question is about the Dalton's law of partial pressure. Why the pilots feel uncomfortable breathing at high altitude? Definitely at high altitude, the pressure is low in unpressurized cabin. So you have to write that the oxygen in unpressurized cabin is low as compared to 159 torr, which is on Earth, and we use this temperature especially for the breathing in our Earth. Okay. So now that question five, is about the Joule-Thomson effect and its application. So when we say Joule-Thomson effect, it is written in the properties of gases that when a sudden subtraction of gases occur, cooling take place. It is called Joule-Thomson effect, and the application of this effect can be seen in Lenz's liquefaction method of gases. Okay, so you have to write these two things. The one line you can see in the properties of gases, and this other line you can get in the Lenz's liquefaction method. So this will be the proper way to answer this question. Now, the next part is about to prove partial PA, partial pressure of A is equal to total pressure into mole fraction of A. So what we can do, it's a very simple way, like PA into V is equal to NART. It's actually a general gas equation. PV is equals to nRT at same temperature and at same volume. We have different number of moles, and when we are we have different number of moles, we'll get different pressure. So pressure is directly proportional to number of moles. That's the question actually. That's the drill to solve this question. Now we have PA into V is equal to NART. Similarly, PT into V is equal to TRT. Now what you can do, you can divide the two equations and you will get Na over Nt, which is actually equals to the mole fraction. Okay. So this is mole fraction of A. The question 7 is about the reason for the production of positive rays. Okay. Uh, Actually, the gas that is enclosed in the chamber uh, is get the electrons that are passing, the cathode rays that are passing from cathode to anode. They are actually electrons, and the electron when strike with the atom, they knock out the electron from the gaseous molecules and positive ions are produced. So you have to write this whole along with, like you do not need to cram this thing, but the concept will be here, and you'll use this concept. Okay, differentiate between line spectrum and continuous spectrum. That's very easy. You can see in front of you. This picture I have just added here is actually about the detailed description. So you can see in continuous spectrum, the colors are merged together, while in line spectrum, we have different lines. Every line or every color is separated from the other line. So in continuous spectrum, you can see here it is mentioned. You can read this one, and in atomic line spectrum, volatilized. Okay, so we see distinct lines separated by dark spaces. This is very important to mention in the short question. Okay, and you can give the example as well. Definitely, example is very important. So one more thing, in quantity spectrum, it is actually the property of matter in bulk, while in line spectrum, it is not the property in bulk, but rather it is actually the property of individual atom. Okay, now the state Heisenberg uncertainty principle and give its equation. 1 mark for the principle and 1 mark for the equation. You can see it has not been possible for us to measure simultaneously the exact position and velocity of electrons. Okay, and here we have an equation as well. Okay, what is spontaneous process? Give two examples. So in a spontaneous process, you can see that happens on its own without any external effort. Once, what we can say that we need to start the reaction, some energy is needed to start the reaction, but once it starts, then definitely it will go on its own. You can see three examples here. You can write any two examples. Now, the state function is actually topic 7.2 in your book, which is actually dependent on the initial and final state. So it's a macroscopic property of system that have some definite value for initial and final states. So you can see the examples here as well. You can give example of two-state system. You can use the example of volume, example of an internal energy is equals to E2 minus E1. So you can use these sort of examples as well. You have to write minimum two examples here. Half mark for each example and 1 mark for the definition of the question. Enthalpy of neutralization with an example, you can see that enthalpy of neutralization is very important to understand, because whenever we see enthalpy of neutralization, we are dealing with 1 mole of H positive ion and 1 mole of OH negative ion to produce 1 mole of water. You can see the answer here as well. Okay, now we have the question 3, any 8 question from this portion as well. So what is catalytic poisoning? Give two example. It is actually question 16 in your book, which is an exercise question here. And what you can see, catalytic poisoning happens due to the presence of traces amount of foreign substance, okay, that can influence the effect, the activity of a catalyst, okay. Two examples are here. The presence of carbon monoxide as an impurity definitely decrease the hydrogen rich catalytic activity in Haber's process. And in H2SO4, arsenic poisoning can actually destroy the catalyst, because it can react with the catalyst. We use V2O5 as a catalyst in the production of sulfuric acid. So when arsenic is here, arsenic reacts with vanadium pentoxide and destroy the catalyst. So you can give these two examples that I mentioned in your book. Okay, what are pseudo first order reactions? So there is not appropriate definition. So I'm writing this definition. This reaction occurs when one reacting material is present in great excess or is maintained at constant concentration compared with the other substance. Then these types of order, then this type of order of reaction is actually a pseudo order of reaction. Okay, you can see the example that in the hydrolysis of tertiary butyl bromide, water is in excess. So when water is in excess, then we will not consider water. Water, if the water is limited, then it must be considered, and we'll write this reaction as the order second reaction. How we can write it as a second order reaction? Like rate is directly proportional to the tertiary bromide CH3 whole 3 CBr along with H2O, but H2O is in excess, okay? If it is not in excess, then 1 here and 1 here, so 1 plus 1, that is equals to 2. But it is not a second order reaction because water is in excess, so rate of reaction remain effectively independent of the concentration of water because of being solvent is a very large excess, okay? So it is present in very large excess. Such type of reactions are named as pseudo first order reactions, okay? So you can give the example and you can write the definition. Okay, now the third question is about the activation energy and activated complex. Here you have the definition. The minimum amount of energy required to for an effective collision is called uh, activation energy required to start the reaction. And the transient state, the the short-lived state between reactant and product is known as activated complex. You have both the definitions here. You can write this one. Okay, what is the difference between gauge crucible and centered glass crucible? I got this picture from internet. It's a very good picture, and we must be thankful to the person who made this. Okay, so gauge crucible is made up of porcelain. It has porous space. It needs to cover with asbestos or filter paper. Okay, so the filter paper is reactive to so many things, like it is not useful in filtering sulfuric acid or any concentrated acids or oxidizing agents. While in sintered glass crucible, we can see it in made of glass. The glass disc is sealed, and you can read the other points as well. Like there's no need of alteration, no preparation is required. Okay, it's a very convenient process. So the fifth question is about the decolorization of crystalline substance. Now, most of the students do this mistake that they only write that we can add animal charcoal in decolorizing the undesired color. But the main point is when we have to add the animal charcoal. So such impurities are conveniently removed by boiling the substance. This is very important to understand. By boiling the substance in the solvent. When we are boiling it, we have to add the animal charcoal in it, okay, in the hot solution. Then it will decolorize. So we'll add animal charcoal during boiling of the substance. Okay. How the rate of filtration can be increased by using flooded filter paper? Definitely, flooded filter paper has a large surface area for filtration that will increase the flow rate and loading capacity. Why the boiling point of water is greater than hydrofluoric acid? You can see here that the boiling point of water is 100, while the boiling point of HF is less than 50. Now, the main point here is about that why we are saying this one. Okay, this is the paragraph where we can see and we can adjust it here. Okay, just a minute. It is interesting to note that the boiling point of water seems to be more affected by hydrogen bonding than hydrogen because we have two hydrogen bonds in water while one hydrogen bond in hydrogen fluoride. That is why the boiling point of water is greater than HF. This is the complete answer mentioned over here. So you can read the complete topic 4.1.6 thermodynamic properties of covalent hydrides. Okay. The next question is about why diamond is non-conductor but of electricity, but it is very hard. So 2 points must be mentioned. First of all, we have to write that there are no free electrons in diamond. And the second main point is giant 3D structure. Okay, so it's a big giant three-dimensional carbon molecule. Okay, so it is tightly packed. It's a macromolecule, so there are no free electrons for the movement of electricity. So it is not a conductor of electricity, but it's very hard because of three-dimensional lattice. Okay, what is meant by habit of crystal? What is the effect of impurity on habit of crystal? The shape of crystal with which it will grow is called the habit of crystal. And remember, when we add 10% urea in NaCl, the shape of crystals will be like and will be a little like. Okay, so there is a difference. So you have to write these two things to get complete 2 marks. Okay, define crystal lattice, draw a cubic unit cell. It is in front of you. Crystal lattice is actually the arrays of point rearranging atom, ion, or molecule of a crystal arranged at different sides in three-dimensional space. So this is crystal lattice, and in a cubic system we have all the axes. A is equals to B is equals to C. All the sides are equal. All the angles are equal. Alpha is equal to beta is equal to gamma. That is equal to 90 degrees. So they are asking two questions. That top one is for 4.5 and second is for 4.6. So all of two are mentioned here. You can see. Okay. Most of the students are not able to solve this question completely because they do some mistake in structures. So remember, you have to draw the structures like this. Ammonia is at the angle of 107.5, while CH4 is at the angle of 109.5. So you have to draw the shape. Okay, so these are all the shapes mentioned here, the CH4 and NH3. So you can see the shapes, just need to draw the shapes. Okay, what are X-rays? Okay, there is no proper definition of X-rays that are mentioned in the topic of X-ray, but you can see the definition from this table, this 5.13, in which you will see that we have different frequencies, different wavelengths. So X-rays are actually between zero point 0.1 to 10 nanometers wavelength. So X-rays are the rays having wavelength between zero point 0.1 to 10 nanometers. This is their definition. And how they are produced? X-rays are produced when rapidly moving electron collide with heavy metal anode in the discharge tube. Energy is released in the form of electromagnetic waves when the electron stops suddenly. So these one mark for what are X-rays and one mark for how they are produced. Okay, it's a little technical question and you will not get the answer at the same place. Okay, one answer you can derive from 5.13 diagram and the other from 5 point other part of the question from 5.6. Okay, the question 4 is about the dipole moment. Okay, 4.1. Why the dipole moment carbon dioxide is 0 while a sulfur dioxide 1.61? As you can see that there are two lone pairs in sulfur, and one lone pair is present in sulfur dioxide. So sulfur dioxide is not linear structure, and dipole moment is always a vector quantity. So we have unequal distribution of electrons around the central atom. Therefore, it's have the dipole moment of 1.61 dBi, while the carbon dioxide you can see we have equal forces of attraction around two sides. All the vector sum will be equals to 0. So the dipole moment of vector quantity and vector as well as direction. Okay, everything is in front of you now. So you can see why the dipole moment of carbon dioxide is 0 while sulfur dioxide is 1.61. Okay, what is electronegativity? It is the tendency of an atom to attract a shared pair of electrons toward itself is called electronegativity. Remember, it always increases in period and decrease in groups. So these two things are also mentioned here. Why it is impossible for CH4 to make coordinate covalent bond with its positive ions while water and ammonia can do so. Water and ammonia has the lone pairs. You can see there's one lone pair in nitrogen and two lone pairs in water, while in the case of CH4, there's no lone pair. You know the structure of CH4? It is just like this, CH4 having the angle of 109.5 with no lone pair. So we can say that in coordinate covalent bonds, there's no lone pair. So we have like no coordinate covalent bond, because coordinate covalent bond is the bond that is formed by the complete transfer of lone pair from one atom only. Okay, write the Henderson equation for acid and basic buffer. So you can say pH is equal to pKa plus log of salt over acid. Similarly, you can write the pOH is equal to pKb plus log of salt over base. This is called Henderson equation, very simple. Now, how the equilibrium constant Kc predict the direction of reaction? So in the direction of reaction, we have 3 points. Either the Kc value is high, low, or equal. Okay. So how equilibrium constant predict the direction of reaction? Of reversible reaction. So the direction of chemical reaction at any particular time can be determined by its means of product ratio calculated before the reaction to attain equilibrium. And after attaining the equilibrium, we'll see like what if the values are equal then at equilibrium. If the ratio of Kc is less, then definitely we have the more products and vice versa. Okay, so you can read these 3 points. That will be very helpful for you. Now, write the two uses of buffer. So buffer the solution that will resist the change in pH, and in chemistry we use in the light sciences, molecular biology, microbiology, soil sciences, etc. Okay, it is used to maintain the pH of blood as well. Describe the electrolysis of molten sodium chloride. Okay, so extraction of sodium by electrolysis of molten or fused sodium chloride is carried out in Dawn cell. Okay, so you have to write the reaction at anode, and at anode you will know, you know that at anode oxidation always happens, while at cathode reduction always happens. So these chloride ions will lose electrons to become chlorine gas, while the sodium ion will gain electron to become sodium metal. Okay, so we have now the eighth question here. Calculate the oxidation state of chromium in the following compound. You can see CaCl3, so chloride is -1. -1 into 3, that is equal to 0. X minus 3 is equal to 0. The state is +3. Similarly, you can see that in Cr2O3, we are not familiar with the state of chromium, so I'm writing X. There are two chromiums, I'm writing 2X. And there are, okay, there's a little mistake here. Let me just, okay, plus there are three oxygens and the state of one oxygen is -2. 2x minus 6 is equal to 0, x is equals to +3. So you will do these calculations for writing the states. Briefly explain the function of salt bridge. Okay, so this one is actually written extra here. You don't need to write everything, or you are not supposed to make the diagram. But what you can do, you can write the function of salt with the purpose of salt bridge to prevent any net charge accumulation in either beakers by allowing the negative ions to leave at the right side, diffuse through the bridge, and enter the left beaker. Okay, so when you will read the whole function of salt bridge, you will be easily able to find the answer. Okay, the main function of salt bridge electrically. Okay, so I have written these things as well. That's it. So these are all the short question explained. If you have any problem, you can visit my office for further details. Thank you so very much for listening. Take a very good care of yourself. Allah Hafiz.